Hello friends, welcome to my channel. This is Manna and this video is part of our Spark interview questions and answer series. In this video I'll be talking about UDF in Spark. I will talk about what is UDF. I will talk about why should we avoid UDF. I will talk about performance consideration with UDF in Scala versus UDF in Python. I will walk you through UDF example as well. That will be in part 2 of this video. So let's start. UDF is a user-defined function that make it possible for user to write one's own custom transformation. UDFs are functions that operate on the data record by record, and by default these functions are registered as temporary function to be used in the specific Spark session or context. UDF is very powerful as we can write UDF in several languages. We can write UDFs using Scala or Java or Python or external libraries. Spark serializes UDF functions on driver and transfer it over the network to all executed process. This happens regardless of the language that was used to write UDFs. So I hope by this it is clear to you what is UDF. UDF is user-defined function that allow user to write one's own custom transformation. So this is very powerful, but this comes with penalty of performance. So there is some performance consideration with UDF. So let's look into that. We will talk about them in detail. As I said, UDF, we can write UDF in Scala, Java or Python. When we write UDF in Scala or Java, then it follows it. There is something else happens. When we write UDF in Python, then something else happens there. But one common performance consideration, one common performance overhead, regardless of the language, when we use UDF, is that when we use UDF in Spark, we cannot take advantage of the code generation capabilities that Spark has for its built-in function. What with it this I mean is that when Spark works with its own built-in function, it optimizes the code. It can generate a very optimized code for the user. But when we use UDF, Spark is totally unaware of what is happening inside UDF. It is totally unaware of the structure of UDF, so it cannot optimize user's code for UDF. So this happens regardless of the language that was used to write UDF. So this is very big consideration, performance consideration that has to be considered while writing UDF in Spark application. So other than that, also we have some performance consideration while writing UDF, but that depends on the language that was used to write UDF. So let's talk about them also. When we write UDF in Scala or Java, then there's a cost of object instantiation and garbage collection overhead, because in Java and Scala UDF runs within JVM. When we write UDF in Python, then there something else happens. It's UDF pass through Python process, and after executing UDF, this Python process returns results to JVM and Spark. Spark starts the Python process on the worker, serializes data to a format that Python can understand, executes the function in the Python process, and then finally returns results of the operations to the JVM and Spark. Starting Python process itself is expensive, but this is not a real cost. Real cost is serializing data to Python, and also once data enters to the Python, Spark cannot manage memory after that, and that could cause worker to fail, because JVM and Spark both would be competing for memory on same worker. So now it is clear to you that we should stay away from UDF as much as possible. But still, if we are in such a position that we cannot achieve our business logic without custom designed function, then it is better to write UDF in Scala or Java and then use that in the Spark application. UDF written in Scala or Java can also be used in the Spark application written in Python. So let's go to UDF example, but I will talk about this UDF example in next video. For this video, that's all folks. So I hope I was able to make some difference to your learning. Thank you. Thanks a lot for watching my video. Please subscribe to my channel. Please give your suggestion and feedback in the comment section so that I can improve quality and content of the video. Thank you. Thanks a lot for your love and support. Thank you. Namaste.